All right, hey everybody. So now we're going to solve systems of equations by elimination. All right, so these are some steps in case you're a person who likes to follow exact steps that you might want to just jot down some quick notes for or take a picture of and follow these steps until you get comfortable with it, okay? I follow them not quite to a T, but I do follow them pretty close almost every single time. And I didn't memorize them. It's just, it makes sense. Once you get to working with these, you'll see what I'm talking about. So you might want to hit pause if you're taking notes. All right, so this is a system of equations. We have two equations, and we have two unknowns, okay? In another class, you could have three equations and three unknowns, but in this class, we're only going to be dealing with x's and y's. All right, so here's what you're looking for. You want both equations to be in standard form. And remember, standard form is when you have your x's and y's on the same side of the equal sign and the constant term, this is a constant term, on the right-hand side or the other side. It doesn't really matter if it's left or right. Okay, the next thing that you want to look at is you want to ask yourself, which variable do I want to get rid of? And here's how I choose. I choose the one that has a 1 as a coefficient, if there is one. There isn't always a variable that has a 1 as a coefficient. So all I'm saying is if there is one, that's the one I choose, okay? And so I ask myself, and by the way, we have two of them here, so we have to make a choice. Are we going to choose to get rid of our x's or are we going to choose to get rid of our y's? Well, guess what? I'm telling you that it doesn't matter, okay? But here's what I'm going to do. I'm going to choose to get rid of my y's. And how I get rid of that is I ask myself, what can I multiply this by so that it's the opposite of -2? Do you see where I'm getting -2 from? Okay, so I would have to multiply this by 2 to get it to be the opposite, okay? But I can't just multiply just the y by 2. I have to multiply everything by 2. This has to get multiplied by 2. That's the rule of algebra, is that you have to multiply each and every term by the same non-zero number, okay? So I've got to distribute a 2 here, here, and here. And I'm just going to write it down right here. So I've got 4x plus 2y equals 14. Okay? Now, all I'm doing is rewriting my second one. I'm not changing anything. I'm not multiplying by anything. I'm just rewriting it. Okay? Now, check this out. I am going to add these guys together. I'm going to add my x's together. I'm going to add my y's together. I'm going to add my constant terms together. Okay? When I add 4x plus x, I get 5x. When I add positive 2y and a negative 2y, they create 0, so they go away. That's what we were hoping for. I'm bringing my equal sign down, and then whenever I add 14 and 16, I get 20. Now I'm going to divide both sides by 5, and I get that x is equal to 4. All right, now I have my x term. How do I find my y term? Well, I take what x is equal to, and I put it in. I could put it either there or there. It really doesn't matter which one. You should get the same answer either way if you do your math right. I think this bottom one looks a little bit easier because I don't have to multiply it by anything. So I'm just going to substitute that in there. So I get 4 minus 2y is equal to 6. To get the y by itself, I subtract 4. I'm left with negative 2y is equal to 2. Divide by negative 2, and y is equal to negative 1. And then we need to write our ordered pair as a proper ordered pair, 4, comma, negative 1. And you put parentheses around that. So there's our answer. Now, can you check your work? Absolutely. I can take this 4, substitute it in for x there, and negative 1, substitute in for y there, and I can see if it makes two true statements. If either one of them is false, your answer is not correct, okay? So make sure that you do check your work. For the sake of time for this video, I'm not going to do it here, but you should check your work, at least with a calculator. All right, so this one meets our criteria of both equations being in standard form. Do we already have opposites though? Check this out. Well, our x's are not opposites. They both have coefficients of +1. But look at your y's. This one has a coefficient of a +1, and this one has a coefficient of a -1. So it's already opposites. I don't have to multiply by anything to create the opposite. It's already there. So I can just add these equations together. X plus x is 2x. Positive y and a negative y create 0. They go away. Your equal sign is there. 10 plus 12 is 22. Now divide both sides by 2. And x is equal to 11. Now we need to find our y. So you can substitute this x in right there or right there. I don't really care. You should get the same answer either way. I like the top one because I like dealing with positive numbers. If I can handle that, if I can do that, I will. All right, so I'm going to substitute 11 in for x. Subtract 11 from both sides. Y is equal to -1. So our ordered pair would be 11, -1. And again, check your work. Even if you just do the math in your head, 11 plus -1 is 10. Yep. 11 minus -1, which really means +1, 11 plus 1 is 12. That's true. So I know that this is the correct answer. All right, so on this one, we do have both equations in standard form. We don't have opposites, but is there one of these that I could easily multiply by some number to get it to be the opposite? Well, if I can't multiply something by 3 and get it to be 5. No, I can multiply something by 2 to get it to be a 6, but I need a plus up here, don't I, for it to be opposites? So I'm going to need to multiply the top one by -3. -3, if I multiply by -3, right here, I'll get a +6y, and that's what we're hoping for, okay? So -3 times 3x, -3 times -2y, and -3 times -2. So I get -9x plus 6y is equal to +6. I'm just rewriting the bottom equation. I'm not changing anything. Now we're going to add these two equations together. -9x and 5x gives me a -4x. +6y and a -6y give me a 0. That goes away. And then 6 and 10 gives me 16. Divide both sides, divide both sides by -4. I get that x is equal to -4. Now let's find y. And again, it doesn't matter which equation you substitute -4 in for. I always go for the one with the smaller numbers if I can. There's not always an easier one. Sometimes it's just hit or miss. So I get -12 minus 2y is equal to -2. I would add 12 to both sides. And then divide by -2. So y is equal to -5. So your x is -4 and your y is -5. Again, even if all you do is grab your calculator, do the math on your calculator. So here's what I'm typing into the calculator. 3 times -4 minus 2 times -5, and then I hit enter, and I'm hoping to get this number right here, okay? And I did on my calculator. Okay, so now we're going to try this one. Always try both equations. 5 times -4 minus 6 times -5, and I'm hoping for a +10 here. Yep, that's what I got. So I know for a fact that this is the correct answer. All right, let's do another example. Okay, so they're both in standard forms. Now, check this out. I cannot multiply 4 by something to get it to be 7. It's not possible. I can't multiply 2 by something to get it to be negative 3. Not a whole number anyway. So what can we do here? Well, that means we're going to have to multiply both equations by some number to get them to be opposites, either your x's or your y's. And it really doesn't matter. So lowest common multiple between 4 and 7 is what, 28? And lowest common multiple between 3 and 2 is 6. So I'm going to go for the 6, okay? I'm going to make my y's 6 and negative 6, okay? So that means I would have to multiply the top one by 2 and the bottom one by 3. And the signs are already opposites, so I don't have to worry about making the signs opposites of each other. All right, so I'm going to multiply 2 times 4x, 2 times negative 3y, and 2 times 9. And I get 8x minus 6y is equal to 18. 3 times 7 is 21x. 3 times 2y is positive 6y. And then 3 times negative 6 is negative 18. Add these guys together, and here's what we get. 8x and 21x is 29x. Negative 6y and a positive 6y create 0, so they go away. Equals, and then positive 18 and negative 18 also create 0. Divide both sides by 29, and x is equal to 0. That's okay, x can be 0. Don't automatically assume you're wrong just because you get an answer of 0. I get it, it stinks to do a bunch of work and get an answer of 0, but it does happen. All right, so now let's solve for our y variable, and you can use either the top equation or the bottom, it doesn't matter. Let's just use the numerator. I'm not putting in x anymore, I'm putting a 0. So that goes away. I'm left with negative 3y is equal to 9. Divide by negative 3. So our ordered pair is 0, negative 3. And again, grab your calculator, type this in. 4 times 0 minus 3 times negative 3 is positive 9. That's good. 7 times 0. And why am I typing in the 0 and stuff like that? I always go back to the original problem and I type in the whole thing. Because if you try to do math in your head, if you make a mistake somewhere back here, it's easy to follow those mistakes, okay? And so it's always a good idea to go back to your original equation to check your work. Plus 2 times negative 3, and I'm hoping for a negative 6, and that's what I got. So I know for sure that the system has a solution at 0, negative 3. All right, so sometimes we have these fractions, and they are ugly to have to deal with, okay? So my recommendation is multiply by whatever you need to multiply by to get rid of the fractions, and then make your opposites, okay? So to get rid of the fraction in the top equation, I would have to multiply by 2, which is your common denominator between all three of these numbers, okay? So if I multiply everything by 2, I get 2x plus 2 times 1/2 is 1. All right, and so the bottom equation, we need to look at what the common denominator is between 2, 3, and 2, and that's going to be 6. So we're going to multiply by 6, and that will get rid of all of these fractions, okay? Now, if you are not good at multiplying by fractions, then you need to get a calculator that has a fraction button, and the calculator that I recommend in the syllabus does have a fraction button. So 6 times 3 over 2. Here's how I do this fast in my head. 6 divided by 2 is 3. 3 times 3 is 9. 9x. Okay? right here, 6 times 2/3. 6 divided by 3 is 2. 2 times 2 is 4. 6 divided by 2 is 3. 3 times 17 is 51. All right, now let's take a look at these guys and decide what we want to get rid of, which variable we want to get rid of, and how we can do that. So here's what I'm going to do. I can't multiply 2 by something to get it to be a 9, so that means I'd have to multiply top and bottom by something in order to get rid of my x's. I'm going to try to skip a step if I can, which I can with this variable right here. How do I get this variable to be the opposite of this one? Well, by multiplying by -4, okay? So now I'm going to multiply -4 times each piece here, and I get I'm just rewriting the bottom equation. Now let's add these equations together. These two, okay? -8x and a positive 9x gives me a positive x. -4y and a positive 4y creates 0. They go away. Oops, did not mean to do that. -48 and a positive 51 give me a positive 3. So x is 3. All right, now I'm going to go back to my original equation. I'm going to use the top one, and I'm going to substitute 3 in for x. I'm going to subtract 3 from both sides. And then I multiply both sides by 2. Look, that makes that go away. Okay, so my ordered pair, my solution is, okay? Now again, grab the calculator, type it in, see if you get true statements. How many times? Twice. So I would type in 3 plus 1/2, yes, my calculator will do that, times 6, and I'm hoping to get out the number 6. And I did. On the bottom one, 3/2 times 3 plus 2/3 times 6, I'm hoping gives me 17/2. Oops, I keep doing that. And I get 8.5 on my calculator. So then my question to you is 17/2 the same thing as 8.5? How many times will 2 go into 17 without going over? 8 times with 1 left over. So 17 over 2 is 8.5. So we did good here. This truly is the solution. Okay, so for this one, they still want us to solve the system by elimination. But this one is written in slope-intercept form. Well, kind of. If you swap these two places, it'll be in slope-intercept form. This one is standard form. But it's easier to do elimination when both equations are in standard form, okay? So let's turn this one into standard form. All right, so first thing I would do is I would move my x term to the left side of that equal sign. So I get 3/4 x plus y is equal to 3. Now, it's so much easier to deal with this whenever we can deal with whole numbers, right? So I'm going to get rid of this fraction right here by multiplying by 4, okay? And if I multiply by 4, then my x's, or my coefficients will be whole numbers, okay? But if I multiply by -4, I'll still have whole number coefficients, but then I'll have opposites. And that's what we want. We want either our x's or our y's to be opposites of each other, okay? So when I multiply -4 times this, the 4's cancel and I'm left with -3x, okay? Then if I multiply negative 4 times y, I get negative 4y. And then if I multiply negative 4 times 3, I get negative 12. Okay, so I'm rewriting this one right here. And I'm going to write this one just underneath it. Okay, but look what happens whenever I try to add these together. 3 and negative 3 create 0, right? So that goes away. Okay, let's look at this one. Oops. Sorry, I didn't mean to put that mark there. Okay, 4 and negative 4, 4y and negative 4y, those create 0 also, so they go away. Check this out. 12 and negative 12, those create 0, and that goes away. So I am left with 0 equals 0. Is that a true statement? Does 0 equal 0? And in this case, well, in all cases, 0 does equal 0. And so this would be one of those situations where we would have an infinite number of solutions. Okay, anytime you're left with something that does make sense, 0 does equal 0, then you have infinite solutions. Okay, let me show you something else with this problem. Okay, I want you to look at this equation right here. Notice your y-intercept is 3, your slope is negative 3/4, right? Okay, let's turn this one into slope-intercept form and let's look at the slope and the y-intercept. Okay, so I've got 3x plus 4y is equal to 12. I'm going to subtract 3x from both sides. And I would divide by 4. Check this out. I end up with the exact same y-intercept. Now, keep in mind, their order is swapped, and that's okay. But the y-intercept is now first. So the y-intercept is 3. The y-intercept down here is 3. The slope down here is negative 3/4. Oh, look at that. The slope up here is also negative 3/4. That means these guys are the exact same line. Okay? These two equations are the exact same line, which means they have infinite solutions. Okay? Alrighty, I hope this helps. Let's move on. All right, so let's look at this one. What can I make easily that would make opposites? Let's see here. I could multiply the bottom one by 3. Yep, that would work. Let's multiply the bottom one by 3 and see what happens here. So the top one I'm just rewriting. The bottom one becomes 6x minus 15y is equal to negative 15. When I combine my x's, I get 0. When I combine my y's, I get 0. And whenever I combine these two, I get negative 5. So what you end up with, notice you don't have a variable. Both variables went away. When you are left with something ridiculous like 0 is equal to negative 5, that is never okay. Now, you might be asking yourself, how is that different than the last one? Let me show you real quick. I'm going to go back a page. Notice right here, we had 2x is equal to 0. We still had a variable. Both variables didn't go away. That's very different than this problem where both variables went away. Okay, so 0 is equal to negative 5, which is not true. 0 is never equal to negative 5. And so in this case, this is one of those rare instances, but they do happen. There are no solutions. That means that these lines right here are parallel to each other. They never ever cross each other. All right, so now we've got some word problems here. So solve applications of systems of equations. The sum of two numbers is 39. Okay, so we're going to let x equal our first number, and we're going to let y equal our second number. And I know that x plus y is equal to 39. Their difference is 9, so x minus y is 9. Okay, Now notice we already have opposites of each other with these y's, so we can go ahead and add these equations together. X plus x is 2x. 39 plus 9 is 48. Divide by 2. X is equal to 24. Okay, so I can take this 24 and substitute it in either equation. It doesn't really matter. I'm going to do the top one. I like dealing with positives when I can. So 24 plus y is equal to 39. Subtract 24. So y is equal to 15. So the two numbers are 24 and 15. Now, check your work. When you add these together, do you get 39? When you subtract this from that, do you get 9? Yep. All right, so Joe stops at a burger restaurant every day on his way to work. Monday, he had one order of medium fries and 2 small sodas, which has a total of 620 calories. Tuesday, he had 2 orders of medium fries and 1 small soda, for a total of 820 calories. How many calories are there in 1 order of medium fries and how many calories in 1 small soda? All right, so we're going to let x equal the number of calories in medium fries, and we're going to let y equal number of cals in a small soda. Okay, now you don't have to use x and y. You can use f and s if you want. I hate using s as a variable only because a lot of people's s's, mine included, look like 5s. So I try to steer clear of using s as a variable. I stick with x's and y's, but make sure that you do this step and define what your variables are. It'll make your life easier later in the end, okay? So on Monday, he had 1 order of medium fries. So that's 1x, or just x. But he had 2 small sodas, and that was a total of 620 calories. Okay? On Tuesday, he had 2 orders of fries and 1 small soda, and that was 820 calories. Okay? So now we've got our 2 equations, which, by the way, this is the hardest part. Okay? So we can make either our x's or our y's opposites of each other. It doesn't really matter with this problem. It won't. It's the same level of difficulty either way. So I'm going to multiply the top one by -2. I'm just rewriting the bottom one. Okay, so our x's go away. They're opposites of each other. Our y's become -3y, and then this becomes, and then divide everything by -3. Okay, so it looks like our y is 140, but what does that mean? Y is the number of calories in a small soda. So it says that there's 140 calories in a small soda. Now, some of you are seeing that in your homework, if you don't label your word problems, that I send them back and tell you that I won't give you credit until you label them. If you define your variable up here, I'm okay with you not labeling down here. But again, you have to define what the variable means somewhere on the page, okay? But it's also just as easy to write cals in small soda. Okay, you can abbreviate with me. I'm good with it. Okay, now I'm going to take this 140 and I'm going to substitute 140 in for y into either one of these original equations. It really doesn't matter which one. I'm going to use the top one. And then subtract 280 from both sides. So x is equal to 340. What is that? What is x? X is our calories in medium fries. Calories in medium fries. Okay, so we have 340 and 140. So let's do some math on the calculator and make sure that we're right though. So what I'm doing is I'm typing in 340 plus 2 times 140. And I'm hoping to get 620. I did. Okay, so now I'm going to do 2 times 340 plus 140, and I'm hoping to get 820. And I did. Okay, so I know that these are good numbers of calories for this problem. All right, so you now have learned 3 different methods for solving a system, okay? You learned about graphing, and you saw that on the graph, the point of intersection was where your solution was, right? So you had 2 lines that crossed each other. This right here was the solution, right? If you had parallel lines, those are terrible parallel lines, but nonetheless, if you have parallel lines, there are no solutions. And then if you have 2 lines that sit on top of each other, you have many solutions or infinite solutions, okay? Now, I really don't care what method you use, except in your homework, whenever I say use this method, that means I'm looking to see if you know how to do that method, okay? When it comes to a test or a quiz or something like that, I really don't care. But I will tell you, the easiest thing to do with substitution is when one of your variables is solved for you, okay? So you've got like y equals something, or you've got x equals something. It's easier to use substitution. When you have both equations in standard form, elimination is easier. So you pick the one that makes your life easier. Now, on these 2 problems, I'm not asking you to solve them. What I'm asking you to do is tell me which method might be more convenient, okay? So on part A, we've got standard form, standard form. That means that elimination, I can't write, there we go, would be easier for this one. Now you've got standard form, and then you've got slope-intercept form. That means one of my variables is solved for me. So in this one, substitution would be easier. Okay? So again, could you use substitution on this one? Yep. Could you use elimination on this one? Yes. You'd have to manipulate this to be in standard form first, which kind of makes it a pain in the rear. Or you'd have to solve for one of the variables in this, which makes it a bigger pain in the rear. So I'm just saying, use the one that makes your life easier. All right, that's it for this video. If you have any questions, don't hesitate to reach out.